Hello, everyone. I'm Susan Nash, AAPG, and I'm thrilled today to have the opportunity to introduce you to Seth Champness of DrillCool. And he has a really amazing technology for cooling the drilling mud in geothermal systems. So Seth, please tell us a little bit about yourself and DrillCool.
Yeah, thank you, Susan. My name is, like Susan said, Seth Champness. I'm the president and CEO of DrillCool Systems. We're a well control company, and we've been around since the mid to late 70s. As you said, we started out in geothermal, and we were really there for the geysers and for geothermal fields in Southern California, and then later on in Indonesia and Japan. Since then, really in the mid to late 90s, we branched out to oil and gas, and it's become our mission to be the leader in well temperature control around the globe. Our focus areas are in the US, largely on unconventional resources in Texas, Louisiana. Really over the last 10 years, our focus has been on service. So our goal is to have the best customer service and most reliable equipment available in the North American market. We also serve in the Middle East, Australia, as well as Canada and Mexico. And I think it's important to point out, as Susan said, we are an innovative company. We're constantly updating our equipment to meet ever-changing well requirements. Those of you who do know, depending on where you're drilling in the world, there are different heat load requirements, just depending purely on the resource and then the geology beneath the feet. And I think something that's important is to have a company that's constantly matching their equipment on the surface for what they're seeing in the geology down below, and to make sure that they're staffed appropriately for that. And another piece of us is really focused on the engineering. So there's a whole thermal hydraulic simulation portion that goes with this, not just to predict heat load for designing equipment, but also for determining the best way to drill the well in order to reduce your downhole temperature and overall mitigate risk for downtime and for safety events that you might have due to high flow line temperatures. And finally, our last piece of technology we've been working on is insulated drill pipe. As you know, there's already insulated drill pipe out there. DrillCool ran our first string in 1998, and we've been ever progressing in that. Our goal really is for the Texas, Louisiana area to be over the next 3 to 5 years to be drilling with RSS just by reducing downhole temperatures. So that's back over to you. Thank you for this opportunity to present a little bit about ourselves.
I have so many questions. Okay, so first question. So where are there issues of like hot formations in shale plays? Because it's a little bit surprising to me.
Yeah, and I think obviously the Haynesville is a very hot formation. The Eagleford, it really depends on where you end up as far as your TBD. And I think something that surprises a lot of people is really how you drill the well impacts your downhole temperatures. So someplace you never suspect it is in the Utica and Marcellus. It's not a very hot formation, but the way the wells are being drilled in those formations, you actually end up drilling at or over what the static formation is, really due to largely hydraulics. So it's not just your geology. There's also a little bit going on there with well design, and we're here to help our customers understand that. So again, shale, mostly it's Texas, Louisiana, just due to the Haynesville and Eagleford formations. But we see it all over Pennsylvania, Ohio, Colorado, and
that's super interesting. Yeah, it totally makes sense, especially with the drill speeds. You can see that there'd be a lot of kinetic energy that would translate to thermal.
That is correct. Yeah, and thermal, and I think something a lot of people don't realize is there are a lot of frictional forces being translated, but if you look at an overall energy balance in the well, there's a significant amount of hydraulic energy being put in. It's actually not a very efficient process. You're converting less than 10% of the energy you're putting into the fluid and the drill pipe into cutting rock. So, your ultimate goal is to cut rock and bring it to the surface, and using less than 10% of the energy you're consuming to do that. It's not exactly efficient. So.
Wow. So, okay, now a question on the insulated drill pipe. Is it using a composite or some kind of polymer?
So we have both. Our original string was pipe and pipe design, and it's limited really the geothermal applications, and we also have a polymer design. And that polymer design is ever progressing. Like I said, we're looking at trying to get down to RSS temperatures with that polymer design.
That's really interesting, because I think it's fascinating to look at insulated pipe to like avoid overheating the drilling mud. But on the converse side, there are a lot of issues with ground source geothermal and the heat exchangers that are used there, that oftentimes, if they're like the low density polyethylene, they're actually not conductors, but insulators. So they're not really the ideal material for their purpose. So those things are evolving.
Yeah, and that polymer technology, if you really got into it, they're actually making those more composite now. The reason why they're using one for erosion, one for cost, because not a surface area they have to put in the ground. But in saying that, something they've got good at is actually making polymers conductive. With these different additives, we're going the opposite direction.
Yeah.
We're trying to figure out how to make it better insulators, like I said, in order really to get down to the RSS range. So there's a whole science and chemistry there. We've been at it for the last 5 to 7 years. We've had a few strings. We're not quite where we want to be, but we see a light there.
That's really interesting. Well, so glad that you'll be at Your Tech. So look forward to your presentation there, and also look forward to continuing developments. If somebody watches this after Your Tech, we'll have contact information in the show notes.
Thank you, Susan.
Thank you.